Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at some PSSA big ideas. Alright, so living in Pennsylvania, we take the standardized test called the PSSAs. And so we're going to be looking at some big ideas of what's going to be on the test, starting with operations with integers, specifically positive and negative integers. So let's review the rules that we've learned about integers from the beginning of the school year, starting off with addition of integers. And when I say adding integers, I'm talking about when there is an addition symbol in between. Do we always end up adding? No, it depends on the sign of the numbers that we have in the problem. So if we have a negative plus a negative, then we will add their absolute values in our head, and the answer will stay negative. For example, negative 12 plus negative 4 gives you negative 16. But if we have a negative plus a positive, then we will not add because they have different signs. We will instead subtract their absolute values in our head. Will the answer be positive or will the answer be negative? Well, it depends on who has the greater absolute value. For example, negative 12 plus 4 gives us negative 8. In this case, the negative number had the bigger absolute value. But if it's 12 plus negative 4, then that's going to equal positive 8. The negative 4 does not have the bigger absolute value. The 12 has the bigger absolute value, and 12 is positive. It's not about which number is first. It's about which number has the bigger absolute value. If the bigger absolute value is the negative number, then the answer will be negative. If the bigger absolute value is the positive number, then the answer will be positive. Next, what about subtracting integers? I'm talking about what do we do when there is a subtraction symbol in between. Well, here's the rule that we learned. We learned that we can make every single subtraction problem become adding the opposite of the very next number, because they are the same thing. They are equal. They are equivalent. So we learned that negative 31 minus 6 could become negative 31 plus negative 6. And then you can use the rules of adding integers, which we had learned about we just reviewed it. And so negative plus negative, you'd add in your head, and you would get negative 37 as your answer. We learned that if it's 8 minus negative 2, we can make that 8 plus positive 2. Again, we're making subtraction become adding. We're making the very next number become its opposite sign. And if you recall, I allowed you early on in the year to make the adding the opposite done on the original problem. You don't have to do it off to the side. You are allowed to do it on the original problem. Add the opposite. Same thing on the next one. Negative 7 minus negative 10 is the same as adding the opposite, so it makes it negative 7 plus positive 10. And then since it's a negative plus a positive, you subtract in your head, and 10 has the bigger absolute value, so the answer would be 3. And that's a quick review on adding integers and subtracting integers. Now, let's quickly talk about multiplying integers and dividing integers. The nice thing about these two operations, multiplication and division, is that they have the exact same sign rules as each other. So, if you have a negative times a negative, or it could be a negative divided by a negative, same kind of sign rule. Negative times a negative or negative divided by a negative will always give you a positive answer. But if you're multiplying a negative and a positive, and it doesn't matter which order it could be, the positive number could possibly be first and the negative number be second, or if you're dividing a negative and a positive, and again, the order wouldn't matter, then the final answer would always be negative. It does not matter when you multiply or divide. It does not matter who has the greater absolute value. Even if the positive number has the bigger absolute value, if you are taking a negative times a positive, you will always get a negative answer. All right, now that we have reviewed those rules, I would like for you to try 9 problems on your own. So, write these down on a separate sheet of paper. These are not on some kind of guided notes handout. Do these problems on a separate sheet of paper, then hit play when you're ready to see how you did. So hit pause now, do these problems, then hit play when you're ready to see the answers. All right, I hope you have already done numbers 1 through 9. Let's see how you did. Problem number 1. Notice it had subtraction. We should have made it adding the opposite right away. If you did not, I highly suggest you do that, because now you're going to understand why you would add in your head, because it's a negative plus a negative, and that's going to give you a negative 46. Add in your head. Problem number 2, there was not a subtraction symbol in between, so you're not going to make it adding the opposite like we did on number 1. But since it's a negative plus a positive, you should have subtracted in your head or probably off to the side on this one, because this one's going to need a little bit of borrowing. And you guys remember how to borrow here from elementary school. The 6 would become a 5, and then you would make the 10 added to the 3 to get 13. You would subtract, get 45. Now, should it be positive or negative 45? Negative 63 has the bigger absolute value, so the result would be negative. Problem number 3, subtraction is on the original problem. Did you make it become adding the opposite? And that makes this problem become really easy then, because then you have a positive plus a positive. You will naturally just add in your head like you would in elementary school with a positive plus a positive, and that's going to give you 57. Problem number 4, there is not subtraction in between, so you should not make it add in the opposite. It is kind of like number 1 in the fact that we have a negative plus a negative, and that's going to give you a negative 22. Add in your head. Problem number 5, we have a positive plus a negative, different signs. You should subtract in your head or possibly off to the side. Again, this problem would need a little bit of borrowing, just like problem number 2 did. The 6, again, would become a 5, just like it did on problem number 2, and the 0 becomes a 10, and you subtract, get 31. Now, since the negative number has the bigger absolute value on the original problem, this is why the answer is negative. Problem number 6, we had subtraction. Did you make it become adding the opposite? And then, since it's a negative plus a positive, you subtract in your head and get 11. It's positive 11 because the positive 25 has a bigger absolute value than the negative 14. Problem number 7, we are no longer adding or subtracting. We are multiplying or dividing on 7 through 9. So problem number 7, positive divided by a negative, it's going to give you a negative answer. It does not matter that the positive number had the bigger absolute value. As I was explaining before, if it is a positive divided by a negative or negative divided by a positive, the answer will always be negative. And so that's what we have here on problem number 7. Same thing on number 8. We have a positive and a negative. This time we're multiplying, and that's going to give you negative 36. Hopefully you remembered that when you have a negative 4 right next to parentheses with nothing in between the negative 4 and the parentheses, then that means multiplication. Problem number 9, we have a negative divided by a negative. That is going to give you, whoa, typo, that is not going to give you a negative. What in the world is Underkoffler doing here? This should be a positive 21. Forgive me for the typo, that's kind of funny. Even Underkoffler can make mistakes, but you got to fix your mistakes. All right, we have another problem for you. This one's a little bit different. It's multiple choice, and now it is showing the problem graphically with drawings done over number lines. So take a look at A, B, and C. Take a look at the original problem, negative 6 minus 5. Let's see if you can figure out which one is correct. Hit pause, figure out which one's right, then hit play when you're ready to see how you did. All right, well, hopefully you've already done this problem on your own. First thing I would do is I would make the original problem become adding the opposite because it did have subtraction in between. And we make that become adding the opposite. So we have negative 6 plus negative 5. There are a couple different ways you can do this. First of all, you can figure out what is negative 6 plus negative 5. Well, that would be negative 11. And you can just kind of look at these three answers. Which one's ending up at negative 11? And that would be here choice A. But there's another way of thinking of it. Negative numbers should go to the left. And so if you look at choice A, it goes left 6, and then it goes left 5. And that would make sense for a negative plus a negative. They're both going to the left on the number line. Choice B does also go left 6, but then it went right 5. That's probably what a kid would choose if they did not make subtraction become adding the opposite on the original problem, and they saw that positive 5. They might have gotten fooled into choosing choice B. But it shouldn't be. It should be choice A. And then choice C is just completely wrong. It's going to the right 6. It should be going left 6. All right. Let's now go back to the PSSA Big Ideas paper. On the second page or back side, depending if you printed this on the front and back, of the PSSA Big Ideas from where there was operations on integers on the first page. The second page is on operations with rationals, specifically fractions and mixed numbers. The word rationals could also include decimals. It actually could also include positive and negative integers or even whole numbers, but we're going to look specifically here at the rules of fractions and mixed numbers. So addition and subtraction have very similar rules. Whenever you add or subtract, things have to be alike. So you're going to have to rename the problems with common denominators, whether you're adding or subtracting. Of course, however you change the denominator is going to change the numerators in that same way. And so you'll see that here on the example I gave you for adding mixed numbers. We had denominators of 5 and 20. So we think in our head, what are the multiples of 5? What are the multiples of 20? What's the lowest they have in common? And it would be 20. And so to rename the fractions with a 20, you're going to have to ask yourself, what times 5 makes 20? Well, that would be 4. So you take the numerator times 4 as well, and that's how I got 8 20ths. Then you would ask yourself, well, what about going from 20 to 20? Oh, wait, they're already the same. Well, then that's why the numerator just stayed the same, because that fraction did not have to change. It was already over 20. And then you will not add the denominators together. 20ths plus 20ths stays as 20ths. You will add the numerators. 8 plus 3 is 11. You'll add the whole numbers. 7 and 1 will make 8. Now, I kept these rules simple. I did not throw in any positives and negatives. Obviously, if there were positives and negatives, then you would have to use the rules that we were just reviewing for, how you add positives and negatives. All right, what about subtraction? Pretty much the same as addition. Again, you would have to figure out what's the lowest common denominator of 3 and 7, and hopefully you would figure out that would be 21. You'd ask yourself, what times 3 is 21? It would be 7. Multiply the numerator times 7 then as well, and you would get 14. You would ask yourself, what times 7 would make 21, and that would be 3. So you take the 6 times 3 as well, and that gives you 18. But here's where subtraction problems could get a little trickier than addition problems. You need to check to see if borrowing is needed. Well, how do you know if borrowing is needed? Do some side work. Line them up vertically, one on top of the other, and ask yourself, is the numerator on the first fraction bigger than the numerator on the second fraction? Because if it is bigger, then we would not need to borrow. But here we have 14 up on top, 18 on bottom for the second fraction's numerator. 14 is not bigger than 18. So we cannot take away 18 from 14. We're going to have to borrow. So the 84 becomes 83. And I hope you remember the trick here. The way that you will borrow with mixed numbers, the one whole that you borrowed from 84 is a full 21 out of 21. And that's why you're going to add the denominator's value of 21 plus the old numerator of 14 to get the new numerator, which is 35, as you see here. Again, shortcut trick, take the denominator's value, add by the numerator's value. That will give you the new numerator anytime you have to borrow. And I'm not saying you would always have to borrow. If the numerator on top of the first fraction was already bigger than the second fraction's numerator, then I would not have needed to borrow. But on this one I did. And then after I borrow, then I can subtract at 53 and 17/21. Always check to see if your final answers can reduce. On both of these answers, they did not reduce because 17 is only divisible by 17 and 1, and 21 is not divisible by 17, so that does not reduce. Likewise over here, 11 is only divisible by 11 and 1, so you just have to ask, is 20 divisible by 11? It is not, and therefore, this is going to already be in simplest form. Now, let's talk about multiplying mixed numbers and dividing mixed numbers. In both of these situations, you're going to need to make them improper fractions first. This is something you do not have to do when you add or subtract, but it is something you have to do whenever you multiply or divide. Now, with multiplication, there is a very awesome thing you can do, which will make the multiplication easier. You can reduce diagonally, which really means you can reduce any numerator with any denominator. So if you look here, 5/21 times 2 1/4, the first thing I do is I make the 2 1/4 become an improper fraction, 9 1/4. Then I ask, is there any numerator and any denominator that can reduce? Well, 9 and 21 are both divisible by 3. So that's exactly what I did. I divide them both by 3. That gives me 3, because 9 divided by 3 is 3. And 21 divided by 3 is 7. The reason I would want to reduce numerators and denominators before I multiply is because it makes the multiplication very easy. Because now you have small numbers to multiply by, and then you don't have to reduce at the end if you reduced as much as you could before you multiplied. And to clarify, you can only reduce a numerator and a denominator. You cannot reduce two denominators together or two numerators together. Now, with division, there is an extra rule, and that is that division is the same as multiplying by the reciprocal, specifically the second number's reciprocal. So if you look here, the very first thing I did is I made the mixed numbers become improper fractions. 16 times 2 is 32, plus 3 gives me 35. 3 times 6 is 18, plus 2 gives me 20. After I make them improper fractions, notice there's still division. Next step is where we multiply by the second fraction's reciprocal. And the reciprocal of 20/3 is 3/20. And the division becomes multiplication as soon as you do the reciprocal. Now, can you reduce diagonally with division problems? The answer is no, not when there is division in between, but you are allowed to reduce after you have made it times, after you've made it multiplication. And so that's what I did here on this example. I did not reduce the 20 and the 16 when there was division. Even though I was tempted to, they're both divisible by 4, I did not, because there was division in between. You can only reduce diagonally when there is a multiplication symbol in between. So after I multiply by the reciprocal, that's when I look for the 35 and the 20 and see that they're both divisible by 5. 35 divided by 5 is 7. 20 divided by 5 is 4. Then I can multiply, and since I reduced as much as I could before I multiplied, then my final answer was already in simplest form. It's still good to kind of check, like 21, what is it divisible by? 3 and 7. Is 64 divisible by 3 and 7? No. 21 is also divisible by 21 and 1. Is 64 divisible by 21? You could check. 21 can make 63, but not 64. So this is already in simplest form. All right, now that I've gone over the rules of how to add, subtract, multiply, and divide fractions and mixed numbers, try these 3 problems on your own. So hit pause, do these 3 problems on your own, and then hit play when you're ready to see how you did. Okay, I hope you've already done these 3 problems on your own. Let's see how you did. Problem number 1, we have multiplication. Did you make them improper fractions first? Then, did you look to see if you can reduce diagonally? The 30 and the 8 are both divisible by 2. The 7 and the 21 are both divisible by 7. 30 divided by 2 is 15. 7 divided by 7 is 1. 21 divided by 7 is 3. 8 divided by 2 is 4. Now, if I multiply, I will get 45 over 4, which is the same as 10 and 1/4. Because 4 goes into 45 10 times. 4 times 10 is... No, that's not right. Oh my goodness, another typo, Mr. Underkoffler. That shouldn't be 10 and 1/4. That should be 11 and 1/4. So we need to make this become an 11. My goodness, Underkoffler making another mistake. All right, problem number 2. Did you make them improper fractions first? 8, the whole number of 8 is 8 over 1. Divided by -9/4, because 2 times 4 is 8 plus 1 is 9. Then I throw the negative back on. So when I make a mixed number an improper fraction, I kind of temporarily ignore the negative, and then I just throw the negative back in front of the fraction. I typically put my negatives in the numerators. You could put them in front of the fraction instead, but I just personally find it easier for me to throw the negatives in the numerator. Now, notice there is still division in between, but after that, then you will make it multiplying by the reciprocal. And I have to warn you, problem number 2, it was probably very tempting to want to find a common factor that you could divide the 8 and 4 by, but you can't because there was division in between. The only time you can reduce diagonally with a numerator and a denominator is when there is multiplication in between. And on this problem, 8 and 9 are not divisible by any common factor other than 1, and 1 and 4 are not divisible by any common factor other than 1. So there was no way we could reduce diagonally on this multiplication. So 8 times -4 is -32. 1 times 9 is 9. 9 goes into 32 3 times. 9 times 3 is 27. 32 minus 27 would give you 5. That's how you get -3 and 5/9. By the way, if I go over something too fast and you need to hear it again, you realize there is a rewind feature on videos. Feel free to use that at any moment. All right, problem number 3. We are subtracting. And so we have to find the lowest common denominator, which was 45. Now, how did I figure out that the numerator of the first fraction was going to become 6? Because I asked myself, what times 15 was 45? And that would have been 3. So I take 15 times 3, and I also take the 2 times 3. 2 times 3 gives me 6. How did I get the second fraction to have a numerator of 20? Because I figured out that 9 times 5 would make 45. And therefore I multiply the 4 times 5 as well, which would give me 20. Now, the one thing you have to be careful about with subtraction of mixed numbers is sometimes it needs borrowing. And on this one, would we need to borrow? Well, let's see. We have 6 and we're taking away 20. Yep, we're going to need to borrow because the 6 is smaller than the 20. So here's how the borrowing works. The 10 would become 9. Well, then what does the new numerator become over here? You would take 45 plus 6, and that would make 51. Then you would subtract 51 minus 20 gives me 31. 9 minus 2 gives me 7. And the final answer is 7 and 31/45. Now, I would have to double check. Is that in simplest form? Well, it just so happens that 31 is a prime number. It is only divisible by 31 and 1. So the only way this would reduce is if the 45 was also divisible by 31. And it's not. So this is already in simplest form. All right, now we have a more interesting word problem. And it also deals with fractions, mixed numbers. Even a decimal was thrown into this. You will be allowed to use your calculator on this problem. So hopefully you remember how to use the fraction and mixed number key. Let's have you read this problem on your own. You'll notice this multiple choice at the bottom. Hit pause on the video, read this problem to yourself, figure it out, do the work, and then find out which answer choice is correct. Then hit play to see how you did. Hit pause now. All right, I hope you've already hit pause and done this problem on your own. One thing you hopefully noticed is that the problem talked about how the science teacher had a pool of yarn that contained 2 yards of string. But then the problem wants to know how many inches of string remain on the spool. So one of the very first thing I did is I figured out, well, how many inches would 2 yards be? And hopefully you remember that there's 12 inches in a foot and 3 feet in a yard. So what does that mean? That means if you take 12 times 3, that would give you 36 inches in a yard. Take 36 times 2, and that would give you 72 inches. Now what you got to do, using your calculator, is take all the information the problem said. 3 pieces of string, that was 3.25 inches. Multiply that. 3 times 3 1/4 is 9 3/4, or 9.75. I like to keep them all fractions and mixed numbers, so that way I don't have a decimal mixed in with a fraction or mixed number. I like to have them all the same kind of way of writing, so I'm going to make them all mixed numbers here. All right, 1 piece of 4 1/2 is obviously just 4 1/2. 6 pieces of string, that's 5 1/8. We multiply, and that would give us 30 3/4. 9 pieces that are 1/4. Again, take 9 times 1/4, and you would get 2 1/4. Then you would take these 4 results, the 9 3/4, the 4 1/2, the 30 3/4, the 2 1/4, and add them together. That would give you 47 1/4. What do I do with that? I need to find out how many inches of string remain on the spool. Remember, the spool had 2 yards, which we found out was 72 inches. So I'll take 72 inches minus the total that I had from all these kids' yarns or strings of 47 1/4. That's going to give me 24 3/4 inches of yarn or of string left on the spool. And that just so happens to be one of the answer choices, which was choice C. All right, I am not sure how much time we're going to have in class, but it is possible that we might have enough time to get to 3 more problems. And here they are. Problem number 1 is another one of these number line problems with positives and negatives. Problem 2 and problem 3, we have multiplication and division of mixed numbers. So, hit pause on the video, do these 3 problems on your own, then hit play when you're ready to see how you did. Okay, I hope you've already done these problems on your own. Problem number 1, we make subtraction become adding. The opposite, -7 plus -8 would be -15. It looks like choice A would leave me here at -15, but let's double check. Are the lines going in the correct direction? They're both going to the left. Those arrow bars going to the left. Would that make sense for 2 negative numbers here once I made it add in the opposite? Yes, it would. So choice A is the correct choice. Problem 2 and problem 3. I'm going to show you these on separate slides. Problem number 2. Did you make the mixed numbers become improper fractions? Can we reduce diagonally here? Well, 10 and 7 do not have a common factor other than 1 that we could divide by. 3 and 7 do not have a common factor that we could divide by other than 1. So let's just multiply. 10 times 3 is 30. Keep it negative. 7 times 7 is 49. This would be choice C. And finally, problem number 3. Make them improper fractions. Now, I know it's tempting to want to reduce the 6 and the 10 both by 2, but you can't because there's division in between. Make it multiplying by the reciprocal. And then after you make it multiplying by the reciprocal, then you can look to see if there's a way to reduce diagonally. And there is. Both the 25 and the 10 were divisible by 5. Both the 6 and the 3 were divisible by 3. 25 divided by 5 is 5, 6 divided by 3 is 2, 3 divided by 3 is 1, 10 divided by 5 is 2. Multiply, and you will get 5/4, which is the same as 1 1/4, and that would be, whoops, moving the wrong thing here, that would be choice D. And that concludes the video on PSSA Big Ideas, starting with first with operations with integers, positive and negative integers, and then finally operations with rationals, specifically fractions and mixed numbers. Thank you for watching. We'll see you next time.